What's up, folks? Welcome to Math Walkthroughs with Mr. Wiebe. Today we are adding and subtracting mixed numbers. These are our Lesson 5 Your Turn questions. Let's see what those questions are for today. First it says, calculate. We have 3½ plus 2 2/3. First thing I'm going to do is I'm going to rearrange things so that we're adding the whole number parts first, and then we can do the fractions over here. Let's take 1/2 and 2/3 over here. And we can't add these very easily without having common denominators. So let's do this. Multiply them both by 1 in the form of the opposite's denominator. So this is times 2 over 2. This becomes then 3, because 1 times 3 is 3, and then 2 times 3 is 6. That's still a half, just looks a little bit different. 2 times 2 is 4, 3 times 2 is 6. We've got the same denominator, just like that. We can add those together, and we get 7/6. Now, unfortunately, this is an improper fraction. It's more than 1. Essentially, we can rearrange these again and say that this is like 6 over 6 plus 1 over 6, right? We still have 7/6, but we know that this is 1 and 1/6. So now we can add these two things together. We can add the 5 and we can add the 1 and 1/6. So 5 plus 1 and 1/6 is going to be 6 and 1/6. And there's our answer. Let's have a look at the next one where it says 17/3 plus 8/5. I'm going to color code these ones. Here is in red, those ones are blue, and we're going to turn these turn these improper fractions into mixed numbers. So first, 17/3. You could do this with division, and if you know how to do that, go ahead. I'm just going to show you why this works. So 17/3 is like saying 3/3. It's like saying 3/3 plus 3/3. Okay, we've got 6/3 now, plus another 3/3. We've got 9/3. Now we've got 12/3. Now we've got 15/3, and we just need 2 more thirds to get 17/3. And in a way, this is like saying 1 plus 1 plus 1 plus 1 plus 1 plus 2/3, which is exactly the same as saying 5 and 2/3. A simpler and maybe faster way to do this is to use division, right? How many times does 3 fit into 17? Well, we know it happens 5 times. 5 times 3 is 15. We subtract, we get 2, and we get a remainder of 2. The 3 goes right here, the 5 goes right here, and the 2 goes right there. If that's too much for you, you can think of it as repeated addition all you want. That's just fine. Okay, next let's look at the blue. We have 8 over 5. Well, this is like saying 5/5 plus another 3/5. And that's just 8/5. But it's the same as 1 and 3/5. So now that we have mixed numbers, now we can add them together a little bit more easily. We know that 1 plus 5 is going to give us 6. And then we have 2/3 and 3/5 to add together. So let's see what that looks like. 2/3 plus 3/5, we need a common denominator. So let's go ahead and multiply both of them. We'll multiply this side by 3/3. We'll multiply the other side by 5/5. And we'll find our common denominators. So here we have 10/15. There's our common denominator for 2/3. And we're adding 9, because 3 times 3 is 9, and 5 times 3 is 15. So essentially, we get 19 fifteenths. Again, it's an improper fraction, but we know that 19 fifteenths is just 15 fifteenths plus another 4 fifteenths, which is 1 and 4 fifteenths. If we add that to the 6 plus 1 and 4 fifteenths, we get 7 and 4 fifteenths. And there's our answer. Let's look at the next one. 5 and 1/20th minus 2 and 3/4. Now, when I just look at this one, I know that this 1/20th is very close to 0, right? Because the numerator is much, much smaller than the denominator. Whereas this is much closer to 1 because this number, 3, is very close to 4, right? It's got 3/4 of it, 75%. So when we try to take 75% or 75 out of 100 from almost 0, that's going to be tricky to do. What's less tricky is thinking of subtraction as adding on. What do I need to add to this number to get to this number? So what I'm going to do is I'm going to rewrite the question as 2 and 3/4 plus something will give me 5 and 1/20th. What is that thing that I need to add? Well, let's take it up step by step. If I add a quarter, now I'm at 3. Now, from 3 to 5, I need to add 2. And then I just have 1/20th left to add. So in essence, what did I add? It's everything in red here. So let's add this together. What is 2 and 1/20th plus 1/4? What I need to do is I need to find an equivalent fraction for 1/4 that has the same denominator. What I can do is I can multiply it by 5 over 5, because I know 4 times 5 is 20, and that's my goal. I want to have the common denominator. So it's 5/20ths. Except I should have it in red. Let's redo that. Let's just put that in red. It's showing that we have the same, it's an equivalent fraction here. Okay, so let's rewrite this. We've got 2 and 1/20th plus 5/20ths. And now we have 2 and 6/20ths. And that is how far it is, because we've got 2 and 3/4 plus 2 and 6/20ths, and that will get us to 5 and 1/20th. Finally, we have 2 and 1/6 minus 1 and 5/8. We could do this as adding on, subtraction as adding on again, but instead I'll show you a different method of doing this. Let's see how this looks when we borrow, because we've got the same problem where I know that 5/8 it's more than a half. We're using our benchmarks, and 1/6 is closer to 0. So when we take a half away from 0, that's going to be tricky. So I'm going to borrow from the 2 and add to the fraction part so that subtracting the fraction parts is easier. I'll show you what I mean. So let's change 2 and 1/6, and we know that this is 1 plus 6/6 plus 1/6, right? So now we've got 1 and 7/6. And then what we can do is now we just need to find equivalent fractions for 7/6 and 5/8. So 7/6, I could multiply it by 8 to get a common denominator of 48, but instead I think I'm going to multiply it by 4, and I'll show you why. If we multiply by 4 over 4, we come out with an equivalent fraction of 28 over 24. And I know that if we take 5 over 8 and multiply that by 3 over 3, I know that 8 times 3 is going to give us 24 as well. Now we've got a common fraction, or a common denominator in an equivalent fraction. Okay, so now we can just subtract the whole numbers, and now our whole numbers are 1 minus 1. So that's going to be 0. We're not going to have any whole numbers. And now we can take away the fraction parts. So we've got 28/24 minus 15 24ths, which gives us, well, let's see now, 28 take away 15 is going to be 13 24ths. And that is our final answer. Our next question tells us to show two strategies you could use to calculate this question. Okay, when we look at it again, we're using our benchmarks, and we can see that this is closer to 0, and this is much larger than 1/3 because it's over half, right? 4/8 would be a half, so 5/8 would be past half. So when we're trying to take away a larger number from a smaller number, that means we either need to regroup or we need to think of subtraction as adding on, something like that. So I'm going to show you two different strategies. The first one, adding on. So let's see. Adding on. Let's just label them so that we don't get confused. First one, adding on. What would we need to add to this number to get to this number? So we can rewrite the question like this. 2 and 5/8 plus something is going to give us 4 and 1/3. I'm going to write what we're adding on in red. If we add 3/8, we'll get to 8/8, right? And that'll get us to 3. And if we want to add up to 4 and 1/3, from 3 to 4 is another 1. And then we're at 4, and now we need to add another 1/3. Okay, so everything in red here is going to be our answer to this question. So the next thing we need to do is figure out a common denominator for 3/8 and 1/3. So we've got 3/8 is the same as saying 3/8 times 1 in the form of 3/3. So that's going to be 9 24ths. And 1/3 is going to be the same as saying 1/3 times 8/8. That's going to be 8/24. So now we've got an equivalent fraction for 3/8 and an equivalent fraction for 1/3 that share the same denominator. So let's add those all together. We've got, for 3/8, we've got 9 24ths plus 1 and 8 24ths, which is going to give us the answer to our question. So we've got 1 and 17 24ths. There we go. Our final answer. That was adding on. Let's wall this off, and we'll call the next one improper fractions. We're going to convert these mixed numbers into improper fractions. So we know that 4 and 1/3 is the same as saying 3/3 plus, because that's 1, plus 2, plus another 1. That's 4 altogether, and then 1 more third. And that will give us an improper fraction of 4 groups of 3, which is 12, plus 1, which is 13 thirds. For 2 and let's just show which ones we're doing here by highlighting them. Okay. Next, in red, let's figure out how to convert 2 and 5/8 is the same as saying 8/8 plus 8/8. That's 2 now, plus another 5/8, which is going to be 8 times 2, which is 16, plus another 5, which is 21/8. What we'd like to do eventually is take this number and then subtract this amount from it. However, they don't share a common denominator yet. So let's figure out that first. We're going to go 21/8, and we're going to multiply it by 3/3 so that we can find an equivalent fraction. 3 times 20 is 60, plus another 3 is 63, and then 8 times 3, which is 24. Now we can find an equivalent fraction for 13 thirds. We're going to multiply it by 8/8 so that we get that common denominator of 24. 13 times 8, well, let's see, 8 times 10 is 80, 8 times 3 is 24, so 80 plus 24 is going to be 104 in the numerator here. Now we can do it. We can take the blue number, which is now looks like this. We can take that and then subtract this number, which now looks like this. Let's write it out. We've got 104 over 24 minus 63 over 24. So 104 minus 63 is going to be 41 over 24. And there's our final answer. Now, we could also double check to make sure that we did it right and see what does that look like in a mixed number. So 24 fits into 41 how many times? Well, two of them would be 48, so it can only fit in once. 1 times 24. 41 take away 24 is going to be 17. And so we have a remainder of 17. So this is the same as saying 1 and 17/24. So there it is. They are the same number. It's just that this one looks like an improper fraction and this is a mixed number. Next, let's have a look at number 3. It says, write two types of problems you could solve by calculating 4 1/5 minus 2 2/3. Use two different meanings of subtraction. Okay, one type of problem that I could solve would be this. Subtraction as taking away. I had 4 1/5 cups of sugar and then used 2 2/3 cups. How many cups do I have left? I can also think of it as adding on. I have 2 2/3 cups of sugar, but I need 4 1/5. How many more cups of sugar do I need? That's where we can do subtraction as adding on. What do I need to add to this to get to here? All right, finally, I will just make sure that I don't have to solve my own questions. It just says, write two types of problems you could solve by calculating this. Use two different meanings of subtraction. Yeah, we've made the questions. We don't need to solve them. But we do need to solve this last one. Which expression has a value farthest from the others? Okay, so we better solve these questions. Well, why don't we estimate first, just to see if we can narrow down our options. This question here, A, this is close to 1, this is close to 1. So what if this was 4 plus 5? The answer is going to be close to 9, or just a little less than 9. So maybe we could put it like this, just a little bit less than 9. The next one, B, we've got almost 21 minus just about 8. Okay, so 21 take away 8 is going to leave us with 13. So we can write it's approximately 13. Okay, what about this one when we estimate? We've got 4 plus 8.5, so that's going to be 12.5. So let's write 12.5 approximately. And then we've got 20 1/5 minus 7 3/4. Okay, so 20 1/5 is closest to 20. So if I go 20 take away closer to 8, okay, 20 take away 8 is going to be approximately 12. Is going to be approximately 12. So what it looks like to me is that if this here is less than, if this amount is less than 9 and the rest are all hovering around 12 to 13, my answer would be this, A. And I don't even have to solve them completely. I can just sort of estimate the amount that I would have at the end. That's it for today. Thanks for watching.